Good morning, everyone. Today, we are presenting our project titled ThreatCam Terrorism Detection Through Video Analysis. I am Bineta Mohalik, and alongside me is AP Shakti Gautam. We are from the Department of Aerospace Engineering at the Indian Institute of Space Science and Technology. So, ThreatCam Terrorism Detection Through Video Analysis. Going on with the introduction part. Terrorism continues to pose a significant threat to public safety, especially in crowded public areas like airports, railway stations, and shopping malls. Currently, most surveillance systems rely on human operators, which leads to slower response times and more chances of human error. To address this, we developed ThreatCam, an AI-powered video analysis system that automatically detects weapons like guns and knives in real time. This helps improve both the speed and accuracy of threat detection, assisting security personnel during critical situations. So, coming on to literature review, we also reviewed several existing works on surveillance systems and object detection to understand current limitations, and shape our approach accordingly. So, these are the research papers. With the title of paper, year, optimization goals, technique used, advantages, disadvantages, and research gap. Coming on to problem statement, the problem is simple but serious. Manual surveillance is slow, error prone, and inefficient for large scale video monitoring. There is a strong need for a real time system that can automatically detect threats such as guns or knives. ThreatCam fills this gap by using deep learning to identify weapons directly from video streams, boosting both safety and operational efficiency. Coming on to the motivation, the rise in public violence and the limitations of current surveillance methods inspired us to create an automated system that can detect threats faster and more reliably, thus protecting lives more effectively. So, our objective is to detect weapons like guns, knives, bombs, grenades, terrorists, etc. in video footage, to minimize manual intervention, to achieve high precision and recall through deep learning, to test the system in real world scenarios such as crowded scenes and moving objects. Coming on to the model used, we choose YOLOv5 for this project. It stands for You Only Look Once. It's one of the fastest and most accurate object detection models available. Why YOLOv5? It works in real time, which is crucial for threat detection. It provides high accuracy and fast processing. It's lightweight and easy to train with custom datasets. We trained it on a custom dataset containing images of weapons like guns, knives, and bombs, etc. Many other classes we included. The model takes a video stream as input and outputs bounding boxes with class labels for detected objects. So coming on to the approach we used. So our approach followed five main steps. First one is data collection. We gathered images of weapons and people from various open datasets. Then pre-processing. It's included resizing images and annotating them with labels. Then the third point is the model training. We trained YOLOv5 using custom classes for different threats. Then fourth one is evaluation. So evaluation or video frame analysis is like we evaluated the model using precision, recall, and MAP matrix. And the fifth one is object detection output. Finally, we tested the trained model on video footage to access the real-time performance. So that was the output that the model is detecting everything properly or not. So we detected that and we got the output video and we saw like different bounding boxes were there, uh, showing different labels, different classes over which the model was trained. So these are the five steps of our approach explained. like data set collection, pre-processing, model training, evaluation, and finally video testing. Coming on to the data flow diagram. This data flow diagram shows how ThreatCam processes video input. The input video frames go through the trained YOLOv5 model. The output is a labeled video with bounding boxes highlighting threats. This pipeline ensures a fast and automated end-to-end detected system. So here is the input video. Let me play it. So this is a video of shooting in Paris, like the terrorist video. You can see these are the terrorists coming out of the terrorist vehicles and all, and they have guns, pistols in their hand. So let's see what was the output that was generated by our model. So here we will see the output video. So as you saw, like the model detected the gun, pistols very effectively. So coming on to the conclusion part. So precision 84.4% on average, meaning most detections were correct. Then the recall average at 68.1%, MAP at 0.50 is 74.4%, and MAP at 0.50 to 0.90 is like still indicating reliable performance across multiple detection thresholds. So overall, the system shows strong detection performance, especially for rare but critical threats like bombs and grenades. So now, this is the coding part of our project. You can see YOLOv5 here. So this is the VS Code interface, that is the visual code from Microsoft. YOLOv5 that we can see here, we have downloaded this model from Ultralytics website. YOLOv5 comes with many files that you can see here. Now you can see this file customdata.yaml. So this file contains all the labels like people, knife, pistol, grenade, rifle, gun, backpack, bomb. So these are all the labels over which our model YOLOv5 has been trained. So like we have the train and val. So it contains the dataset for the training and validation purpose. Now, going on to the files that we have created for this project. So first of all, train.py. So this train.py, the purpose of this file is like the script trains the model, and what it does, loads your data set, sets parameters, hyperparameters like batch size and epochs, and train using YOLOv5. And the output from this file is a train model saved at best.pt. Now coming to the val.py. This is for validation. So we can say this is for model evaluation. So what is the purpose of this file? It is used internally during training to evaluate the model on the validation dataset. And talking about the output, it generates the results table. So the table that we presented in the conclusion, the one showing 692 images, precision, recall, MAP, etc. Those 692 images are from the validation set, not training. Now coming to detect.py. So detect.py is this file. So talking about this file, it is for model inference or testing. So what is its purpose? It tests the trained model on a video, image, webcam, or folder, and output draws the boxes around detected objects like the pistol, grenade, bomb, knife, etc., and saves the result. So, like in the PPT, we presented you the input video and the output video. So this was like the input was given and it detected everything like the labels over which the model is trained, and at last output was generated, and output has bounding boxes showing the labels like this is a pistol or this is a grenade or this is a terrorist, like that. So it shows only the labels over which it is trained, and it is trained over the dataset. Dataset has training data, validation data, and testing data. As we said during the PPT presentation, that we collected the data from various sources, various online sources, like Kaggle is also there. Like we trained the model over 6,000, 7,000 data, like images with like supervised learning and then unsupervised type. So like supervised learning we are talking about, there we label the data, like trained the model according to the labels, and then tested, validated whether it is detecting everything correctly or not. So this was all about our project ThreatCam. Thank you so much for your attention. We would be happy to answer any questions you may have. Thank you so much.